Strings and runes in Go are a little different than other languages. Most languages, if you think of a string, it's a group of characters. So this is a string. This here would be considered a string, this line of characters. But in Go, it's a little different. So Go has strings and runes. Now, a string can still be a group of characters, but its characters are called a rune. So each of these are called a rune. Now, the reason that they're called runes is because they need to make it different, because essentially a rune, it's an integer that represents a Unicode code point. So in memory, each of these characters are actually Unicode. So if we open up a browser, let's just go here and Unicode. You can look up, let's go Unicode list. Here we go, Wikipedia. So with Unicode, in memory on disk, it's going to look like this. And its numeric value or decimal value is going to be in this column. Octal is here. This is a description and then the key. So if we look at, let's see here, like number 1. Here, we'll look under ASCII. This number 1 is actually represented by U plus 0031 in memory, or as the number indicates, 0018. This is a whole table of different characters. You're going to have some for capital, you're going to have some for lowercase, ones for ASCII punctuation symbols, Latin symbols, letters, numbers. Everything is represented by essentially it's binary code that translates to Unicode, and that's how the computer knows, okay, you're wanting to type the letter A because it's Unicode 0061, the small letter A. So what it does is for each rune, that's how it represents each of these characters. Because of that, it stores them in memory. This way, instead of just in binary, it's in Unicode, and it translates between those. So that's why they're called runes. So instead of it just being a simple character like most other languages, this treats it more of a lower level in the term of how this character is saved. So you'll notice I already went ahead and typed this one out. I know we normally type these out together, but I figured just for ease of time. Also, I can't type Thai, so we'll just go with what we got. So here, what we're doing is we're pulling in the Unicode standard, UTF-8. That way we can use some things like rune value and rune count and string, things like that, some other functions that we can pull from this package. Again, check the standard library. Tons of great documentation on how this all works. First, we create a variable and we're putting in Thai characters. Why Thai characters? Because let's see what the example pulls. You can put whatever you want in here. It doesn't have to be Thai characters. It can be American, Spanish, it could be numbers, it could be alphanumeric, it could just be a random whatever. Just hit your face on the keyboard and that's what you want to. There's nothing wrong with that. They just chose Thai to make it a little unique. So first it grabs the length. Then what it's doing, it takes the length and this %x. You remember how we find out, okay, these % symbols, where are they from? Well, again, we go to the standard library and we look for FMT, and we're looking for, let's look at this again, %x, base 16 lowercase letters. So if it's an integer, if it's a floating point, or if it's a string, this is what we're working, base 16 uppercase 2 characters per byte. For a large, for uppercase X, lowercase is 16 lowercase 2 characters per byte. So what this is doing is it's taking the length and it's saying, okay, I want you to break this up. It's location 2 characters per byte, and then print those out. So when we look at the output, that's what this is doing here when you run this. First it grabs the length. Okay, the length of this is 18. Now it's giving us 2 characters per byte to represent this whole string here that we have in Thai. So this is the computer language equivalent of this. Starting to make sense? Hopefully. Let's keep going. Next is the rune count. This is where it's taking the characters. Now you notice here, that looks like 4 characters, but it says 6. Why is that? Well, because what it's doing is it's grabbing these and it counts each of these characters. You'll notice here, I like this breakdown because it actually shows the 6. So this looks like 4, but it's actually 6 because this is 2 and this is 2, which that took me a little while to get used to because, hey, I don't know anything about Thai language. I just know I like Thai food. So here's the breakdown. And here again, this is the Unicode. So if we take this Unicode string here, let's copy that. So here it is, Unicode character, so swa. But essentially what it's doing is it's giving us the Unicode and it's telling us where it starts in the memory section here. What it's doing is it's giving us the Unicode for each and every character and giving us one at a time. And it gives us this because we're using this %U and then this %D. This gives us the location. This gives us the Unicode string. So that's where it's getting this from. So now we're going to jump into the next section, decode rune and string. Again, this is doing the same thing. And it's saying, hey, if you find this, then you need a found so swa. Found so swa. So it's doing this in a loop. And that's why we see that in here as it's going through, because this character's in there twice. And that's why it's grabbing this here. So again, this is just showing some fancy ways of how you can count, use, get the Unicode characters, things like that, in strings. And you can break up those strings in their individual rune and be able to work with them. This probably isn't the best of examples, especially for new programmers, but it gets the point across that you can do a lot of things to leverage Go to break up strings. You may need to break up a string, like for example, if you're looking for a certain value in a database table, you can, and it's a string value, and you're looking to pull something out of that string that you need to apply somewhere else, then that's where something like this can come in really, really handy. That's just one of many examples that you'll find. But try this out, type it out, play with some of these things, change the variable, tinker with it. You'll find that these are very handy, very fun. It'll start making a lot of sense if it's not that clear yet. So next video, we're going to talk about structs.